We already know that under high engine load, we're using a portion of the fuel delivered to help control combustion temperature. As load increases, or the load is applied for longer, the combustion chamber and piston will become hotter, and we may want to increase the fuel delivery further to maintain engine safety. Fortunately, with modern ECUs, we now have a few tricks up our sleeve to help achieve this aim. There's no right or wrong way to do this, and the technique will depend on the particular ECU you're using. Rather than deal with specifics, I'm going to talk about a few common ways we can do this. The important part is to understand what we're trying to achieve, which is to gradually richen the air-fuel ratio as the engine is under load for longer periods of time. The first way that we can go about this is to use a fuel trim or compensation table based on either gear or road speed. It's reasonable to expect that if the car gets to, say, 6th gear or perhaps 240 kilometers an hour, it's being driven under sustained high load. At this point in your compensation table, you can simply apply the desired change to your fueling. Another way to achieve this is to use a timer function, which is common in some ECUs these days. The timer function can be configured to work however you want, but in this case, you could set it up to start timing when the throttle position exceeds 80%. You could then use the input from this timer for a fuel compensation table and trim in additional fuel once the engine has been at full throttle for perhaps 8 seconds or more. Lastly, some ECUs have a built-in function that calculates average engine load. In essence, this is a background calculation of engine load versus time, and the longer you're at high load or full throttle, the higher the average load value gets. You can then compensate your fuel map dependent on the calculated average load. If you're using these sort of compensations to target a very rich mixture, then there's a good chance that you will result in a reduction in engine power too. It's always preferable to focus on engine reliability over and above outright engine power, but you need to understand how your compensations may affect the engine and power delivery in use.